Greetings and welcome once again to my new calculus channel. My name is John Gabriel. So, someone that I know, a friend of mine, asked me this question, and he did a lot of calculations. And his last line here is not actually correct. Actually, this line here is not correct. So up to here, up to this point, he's correct. But then when he does this, that's incorrect because you cannot assume that you found in the new calculus, you cannot assume that you found the derivative if you still have n or m in the expression. It must be completely free of x and m, okay? So in order to do that, it's quite a process, quite a lot of algebra. So I'll show you the algebra now. So first of all, I told this friend of mine that the auxiliary equation or the expression is not equal to that, okay? And also, if there's no tangent line at x, so naturally there will be no secant line. I don't know why he asked that, but in any case, then to find this involves a lot of algebra. So first you need to divide the numerator by this expanded expression. And then you find, after the first partial quotient, you find that q of xmn is going to equal to the first partial quotient over this denominator, okay? So, and I didn't make any errors, and I found that it turns out to be this. And just to check myself, it's very easy. I come to GeoGebra, and I type in this function here, as you see at the top here. Okay, that's the Q, that's the auxiliary equation. And then I calculate it down here. Calculate it here where I say Qxmn is equal to this, where these are horizontal distances. M and N are the horizontal distances from this point to this point and from this point to this point, okay? And then I just feed it in, and if I move this along, this gives me the result, by the way. It's always 0, as you can see. So don't believe me? Let's go to text. You see that there is the value of Qxmn. It's this expression here. So actually all I could do here is I could just pull this like this. Oops, did I do that? I don't know if I got that right. How come am I not getting that? Am I not being able to do that? That's strange. Usually you're able to just pull it across there, but it doesn't matter. All right. In any case, it is that. So, and wherever you move this tangent line, it stays 0. Okay, so this is the auxiliary equation. So now you might ask, what's happening here? So very quickly, I'll explain. So my friend here got to this point here. He got to this point here where he said minus 2x plus m minus n over x plus n all squared, x minus m all squared. And that's what he got when he simplified this, okay, when he said 1 over x plus n squared minus 1 over x minus m squared over m plus n. And this was for the function 1 over x squared, okay? That's the function. So he was trying to find the derivative for this, which he did find. But then he decided he was going to break this up, this expression here that you see. This expression here, he was going to break it up into minus 2x over x plus n squared, x minus m squared, plus m minus n over that, right? That's not correct because remember, the derivative can only have terms in x, and it will consist of all the terms that do not have any n or m. So you cannot, this is wrong here, you cannot have m or n. And if you want to set them to 0 when you get to this stage, that's okay. Okay, but you cannot say that you cannot split it up like he did here, because this still has n and m in. So ideally, if you want to get an expression for q of x m n like this, you will do the long division, okay, which means expanding this expression here first, okay, multiplying it out and getting what you see over here, and then you'll find the first partial quotient. That's all you need, and then you get a closed form, right? And the closed form ends up being this, okay? It ends up being minus 2x over x4 plus this, all right? So minus 2x over x4 plus this. In other words, minus 2x over x4, which is actually just minus 2x, minus 2 over x cubed plus q of xmn, right? So I hope I've explained that. It's quite complex, not easy stuff, but I'll also upload this video, this applet, and you can download it and play with it. Sometimes GeoGebra does strange things, by the way. So if you move this around too fast, it may fail. Like, let's see if we do that. Oh, so far so good. Oops, there you go, you see. So now it's kind of made a little boo-boo there. Let's get back to where we were. Oops, there. Okay, so you got to be very careful when you play around with GeoGebra. There you go again. It's not easy to do that. All right. So that's a problem with GeoGebra, not a problem with my mathematics. The mathematics is 100% solid. And if you tried with another package, it should work just fine. If you're not already a subscriber, become a subscriber. Click like, tell your friends about this. Tell your mom and dad, tell your cousins, tell everyone. Tell your teachers, your lecturers. Get them to subscribe. And also become a follower on academia.edu, to which I'll place a link online. My name is John Gabriel. This is a new calculus channel. Till next time, goodbye.